Hello, welcome to this introductory lesson to grade 10 CAPS Trigonometry. I'm going to tell you about sin, cos and tan today, what they are, and tell you a little bit about special triangles. And in later lessons we will look at the following: finding unknown sides, finding unknown angles, and solve trigonometric equations. Okay, so let's get started. What is sin, cos and tan? Sin, cos and tan relate to mostly right angle triangles, and each of the functions are defined as ratios of sides in the right angle triangle. Okay, so you'll see I put up a picture of the Cartesian plane with a point P, X, Y, and distance from the origin R, which we can call the radius. Quite often people don't start with this, but I prefer to start with this and then work over to the OA and H definitions we'll come across. And the reason for that is that we don't always have right angle triangles. And quite often we work on a Cartesian plane and we can't draw a right angle triangle then. Okay, so let's look at sin of theta. Sin with relation to this angle on the Cartesian plane. That's defined as y over r. Very important. Sin, cos and tan gives us ratio of sides. Okay. We can also write that as O over H, opposite over hypotenuse. Okay. Then we have cos, which is x over r, and we can also write that as adjacent over hypotenuse. And then finally we have tan of theta, which is y over x. And we can write that as opposite over adjacent. Okay, so very important, sin is shortened for sine and cos is for cosine. Now you can hear there's a sign in both of them, and there is a relationship between sin and cos. The co comes upon complementary because we know complementary angles add up to 90 degrees, and we will find that if we have sin of an angle, let's say 30 degrees, it will be the same as cos of 60, but we'll get to that in a bit more detail. Okay. Then we have our special triangles. Now they will be the 45, 45, 90 degree triangles and the 30, 60, 90 triangle. Okay, so I'm going to clean the board for a moment. Okay, two triangles. This one's got 90 degrees, 1 and 1, and therefore it's an isosceles right angle triangle, which means these two angles must be the same. So if this is 90 degrees, those two are 90 degrees, we're left with 90 degrees, which means each one is 45 degrees. Next, we can find the hypotenuse, which will be square root of 1. Square root of 1 is 1 plus 1 is 2. So the hypotenuse is square root of 2. Just an implication of Pythagoras. You'll find that we come across Pythagoras quite often in this section of the work. Okay, so now we can move on to the other triangle, which I'm going to divide into two equal bits so that we have 90 degrees here. Those two triangles will be congruent, so therefore the sides are equal, and therefore the 2 is divided equally between those two in 1 and 1. So I've got the we've got the 1. So this will be the square root of 2 squared minus 1 squared. 2 squared is 4, 1 squared is 1, so this will just be the square root of 3. Now we can fill in the angles. So this is an equilateral triangle, which means all the angles need to be the same and therefore 60 degrees. We divided that angle into 2 equal bits, so each will be 30 degrees. Okay, now we can come and define sin, cos, and tan for each of them. So, sin of 45 degrees is equal to opposite over hypotenuse, okay, y over r, and this will be our x, which is 1 over square root of 2. Now, cos of 45 degrees will be x over r, adjacent over hypotenuse, which is incidentally also 1 over square root of 2. Okay, 45 degrees and 45 degrees make 90 degrees. Okay, now let's look at tan of 45 degrees. 1 over 1, which is 1. Now, it's important to realize that this will have a use in grade 11. We know the gradient of a line, the change in y over the change in x. In this case, tan can represent the gradient of a line at 45 degrees. So for every x that we go this way, we go the same amount in the direction of y. Now, I'm going to write sin and cos to each other for a bit and then tan below. Let's start with sine of 30 degrees. Okay, so sine will be this side over that side. Okay, so the opposite over the hypotenuse, which will be 1 over 2. Cos of 30 degrees will be the adjacent side over the hypotenuse. Okay, so if we draw this maybe on the Cartesian plane, 30 degrees, then this will be square root of 3, that will be 1 and 2. So cos of 30, square root of 3 over 2. Okay. Now we're going to do sin of 60 degrees. So this one triangle works quite well. It's the y value over the r value, the opposite over the hypotenuse, which will be square root of 3 over 2. Now interesting, 30 plus 60 gives us 90 degrees, and cos of 30 and sin of 60 are equal. Then cos of 30 degrees will be equal, not 30, sorry, 60 degrees will be x over r, adjacent over hypotenuse, which is going to be a half. And interestingly, 60 and 30 makes 90, and sin of 30 and cos of 60 are both a half. Then tan of 30 degrees will be opposite over adjacent, y over x, which is 1 over square root of 3. And finally, just writing over here, tan of 60 degrees will be opposite over adjacent, square root of 3 over 1, which is square root of 3. So that's the introduction to sin, cos, and tan and our special triangles. Just to finish off, if you have one of these old geometry sets, go and look for the two triangles. You might see they look a lot like this. Thank you very much.